Alright, in this demonstration we're going to be using the Automotive Locksmith Kit number 2, which includes the ACOM2 adapter, to access the double eeprom in a Chrysler Crossfire immobilizer. The same immobilizer is used in the Mercedes C class and E class. I believe that's what it says here. Yes, C class and E class. And we're going to be doing it using something that we have not introduced before, and that is our precision probe set. Because of the size of the leads on the microcontroller, the standard probe set is actually a little bit too big to get around there. So we're going to use the precision probe set, and we're going to hook up the probes according to the diagram, which we'll access on our website. And give me a moment and we'll get that started. Okay, first let's take this out of its case so you can see what we're working with. Pull it out here. And here is I'll turn it around this way since this is the way we're going to orient it in order to access the probes. Here's your microcontroller, and this is what we're going to be attaching to. Here's your crystal, and we're going to be attaching to that crystal as well. So let me show you the precision probe set, which is the connection option that we're going to be using to attach to this part. Okay, here's the precision probe set. Turn it around this way. And the precision probe set, the probes on a precision probe set are, I always, whenever somebody asks me what they're like, and I tell them they're like sewing needles with jaws, okay, because that's about their size. So I tell you what, I'm going to zoom in so you can get a better look. But anyway, with all of our connection options, we have brown through gray, which is 1 through 8 if you're connecting to a serial double eeprom. But in the case of a microcontroller, well, the probes go on specific pins, and when we connect to the microcontroller in this Mercedes, we're going to have to do a couple of special tricks. So I just want you to know what those are. So let me get zoomed in and I'll show you actually how tiny these probes are. Okay, here is a probe next to the pencil lead. So you can see that they are really, really small. Okay, this is the red one, but I don't have the probe body up. Let me move it forward here. And there's a handle that you push right here, a little activation handle, which my finger is on. And I'm going to pull it back, try to keep this so you can see the picture. And I'm going to tilt it up and push on the handle. Don't know why I'm having such a problem here. Okay. There are the jaws. Get this picked up a little bit so you can see it. There are the jaws that come out of the probe. Okay, so you can see they're extended, they're retracted. All right, so you can see the size of the jaws, and these are what go on the pins of the microcontroller. Where the standard probes are just too big, the precision probes will fit. So that is what a precision probe looks like in terms of its size. So now I'm going to go ahead and we're going to start attaching the probes to the microcontroller on the immobilizer. Okay, before I attach the probes to the immobilizer, I'm going to show you where the information is on our website, which shows you how the probes are to be attached. If you go to our website, which is airlabs.com, I already have it loaded here to save time. Down at the bottom of the home page, we have a selector called Locksmith Documentation. And if you click Locksmith Documentation, it brings up sub-selectors below it, okay? And there are 3. They all link to the same page, but the one that we're interested in is this one, which is immobilizer photo procedure. So I'm going to click that. That pops us down onto to the bottom of the page where the different immobilizers which show how to attach are located. So we're going to scroll down until we get to Mercedes, and here is the Mercedes and Chrysler Crossfire. All right, here is the link to the zipped pictures. So let's double click this, and we're going to save the contents, and then we're going to go to downloads and check out the pictures. So we're going to go over to downloads, and there is the Mercedes. So we'll double click that, open it up, and the first photo shows a picture of the immobilizer along with the device type. So if you wanted to choose the device directly from the device selection table, you would type in 68HC05X16, because that's the part. But what we want to look at first are the probes. Okay, and on illustration 2, because of the way that we need to attach to and enable communication to this microcontroller, we have to create a jumper. And basically, here's the jumper. And if you look, we're using the red probe in a different way. We have a white wire, which is here. And the white wire, if you were to follow it over, it connects to the back of the yellow probe. So we've kind of done a bit of a rearrangement of the wiring. And in the video where we discussed the ACOM 2, we brought up the fact that there are probe extensions. Okay, and the probe extensions give you the capability to create some connection configurations which allow you to do things such as this, which enables us to communicate with a microcontroller, which you would otherwise, in most cases, have to unsolder it. And the other thing I'm going to point out here is we have the white probe here from the extension, the probe extensions, attached to this particular pin on the crystal. Okay, simply because that's a convenient place to attach it. So I'm going to go ahead and I'm going to make this jumper, and you can see how we do that. Okay, here is the white probe extension, and these wires just pull off. Okay, so I don't need the white probe yet, so I'm going to set it aside. But I do need the precision probes, and what I'm going to do with the precision probes is I'm going to pull off the red probe, because these just slide off of the end of the wires, and I need the yellow probe. Okay, so I'm going to take the yellow probe and I'm going to slide it off. Now what I'm going to do is I'm going to use this extension, and I'm going to put the yellow probe into one end of it, and I'm going to put the red probe into the other end of it. And now we have created a jumper, which once we attach the probes to the microcontroller, this will allow us to have a connection to a point on the microcontroller which is required to establish communication. Okay, so let me bring the microcontroller, the immobilizer, back over, and I'm going to hook the pins up again, or hook the probes up again. I'm not going to belabor you watching me hook up all of these probes. Okay, so I'm going to hook them up, and I do want to point out something that is important after I get these all attached. So let me do that, and then we'll come right back. Okay, before I hook up the probes, I did want to show you this. I was going to do this before I attach all the precision probes. This is the white probe, and I'm going to hook the yellow wire to the white probe. Okay, why am I going to do that? Because the white probe is eventually going to be attached to the crystal. Okay, so the reason we do this is because the lead that generates the signal, the clock signal to the processor, it happens to come from the yellow wire. So since we're using the yellow probe with our jumper configuration, the white probe serves as the white probe attached to the crystal serves as a very convenient connection point. So that's why we do that. Okay, so let me go ahead and hook up the precision probes, and then we'll continue. Okay, here we have the probes attached to the immobilizer, And I wanted to show you something. This is a trick that I use whenever I'm dealing with the precision probes, and I have a base on which I can basically affix the wires, because the precision probes have such a low mass that they'll move around, and sometimes when they move around they'll become disconnected from the leg. So what I do is, once I get a probe attached to the appropriate leg or pin on the microcontroller, I'll take some Scotch tape and I will tape down the wires so the probes don't move. Okay, that way I'm able to basically minimize my frustration, because the precision probes are so small that once you get them on there, you don't want them to wiggle around and pop off. Okay, so the other thing that I want to point out is notice that I have the yellow wire attached to the the yellow wire attached to the white probe, extension probe, and that is hooked to the lower leg on the crystal. And the other thing that I want to point out is how we use the yellow probe by itself in conjunction with the jumper to span some pins on the microcontroller. So let me zoom in so you get a better view of that. Okay, the thing that I want to show you is that in order to establish communication with this particular microcontroller, we have to span pins 19, 20, and 21. All of those three have to be connected together, and they have to be forced to a logic level of 5 volts. Okay, so the way that we do that is we use the gray probe and we extend the jaws so that it spans pins 19 and 20, and then we use the yellow probe, and the yellow probe spans pins 20 and 21. So basically 19, 20, and 21 are hooked together. Okay, well, we also need to have 5 volts on pin 34. Okay, so pin 34 is where the red probe attached. So if you look, the yellow probe picks up its 5 volts from pins 20 and 21, and through the white wire attaches to the red probe, which is attached to pin 34. Okay, so now we have all of the pins on the part at the appropriate logic levels. So I'll tell you what, I'll put the diagram up so you can see what we're doing here. This is kind of a ratty looking diagram, but it makes the point. Okay, you can see that pins 19, 20, and 21 are hooked together, and over here we have +5 on pin 34. Okay, so that's what we've created with the spanning of the 3 pins with the 2 probes, and then the yellow probe with the white wire over to the red probe provides 5 volts on pin 34. Okay, so that's all of the connections that we need. These are also shown in the diagram from the website, so you can see where everything is. And the next thing that we're going to do is we're going to attempt to establish communication. So let me get the programmer set up, and we'll proceed and do that. Okay, because I have the immobilizer basically kind of locked in place because of the tape, here's the plug, and I'm going to put it on the transition board from the ACOM. You can't really see it because the camera's out of the camera's focal range, but I just plugged it onto the ACOM. Okay, now I'm going to go ahead and start our software, and we're going to determine which part, and I'm going to do that. I can either type it in, but I'm not. I'm going to do what I've done in the past, so anybody that's watching this video for the first time knows how we do this. So I'm going to pick my usual part, 93C56, but in this case we're going to go to the path command, and we're going to go to locksmith, and we're going to go to the librarian by pressing L, and we're going to go over to masked part. Okay. Now the mask number on this microcontroller, I'm not going to try and get down and show it to you, but it's G47Z. So we're going to go down and find that. So let's see, C, D, E, F, G, 47V. Oh, sorry, G47V is the mask number. And if you notice, the part number is 68HC05X32. Okay, well, it's different than the one that we have in the pictures, but quite honestly, little inside information, the X16 and the X32 are exactly the same part. So we're going to have the librarian scan this line and set our part number for us. So we do that by pressing F6. It says device type updated. And now when we go back, exit the librarian and go back to the main command list. Okay, so you can see that the device type has been updated. So the next thing that we need to do is establish communication with the part. And we do that by, first we got to turn on the ACOM. And I'm going to confirm, we're going to press S to confirm the switch settings so you can see. And it says requires async communication adapter, part number ACOM2. Use the command to upload 68HCXX.com program before accessing the device. So what we're going to do is we're going to press spacebar, clear the information display, and we're going to press Z. And there's these options from which you choose, and in this case we're going to press option 1, which is upload the communication program. Buffer upload complete, communication verified. So we're now communicating with the microcontroller in this immobilizer. So now we're going to go to command 5, and we're going to use the get validated command, which is G. So we press G, reading data into the buffer. There's the information that's in the double EEPROM on the immobilizer from the Chrysler Crossfire. Okay, for the Chrysler Crossfire, the procedure to make keys is a cloneout. Okay, so we're at this point almost done. Okay, so the next thing that we're going to do is save this the buffer information to a file, and we'll do that. We'll get out of the buffer. We'll set our path pointer to cloneout. Press enter. So we're to save this from the main command list using command A. So we'll press A, and we're already in cloneout. So we will enter the file name. We'll call it Crossfire. CROSS 5 FIR crossfire.bin, and press enter. Save defined buffer range, yes. So file save complete, directory of files, and we have crossfire.bin right here. Okay, so at this point you would use your transponder programmer, you would navigate to the cloneout directory, you would process this file, your transponder programmer would make keys, and you would then use those keys to start the car and get paid. So that is how we use the various parts of the Locksmith Kit 2, including the optional precision probe set, to read the information in circuit from the Motorola microcontroller, 64-pin quad flat pack package, without unsoldering the part. So at this point, we're finished with this demonstration. So I'm going to just leave it on this screen. And as always, we appreciate you watching. And as always, if you would like information about our products, or want to talk to us about our products, or have any questions, that information is on our website, which is airlabs.com. If you enjoy the content or like the content, we'd appreciate it if you press the like button. That allows YouTube to kind of promote our content to more people. And if you want to see some more content like this, you can subscribe if you so choose to do that. So that pretty much wraps up this video. Again, we appreciate you watching, and if you have any questions or would like to contact us, that information is on our website, which is arlabs.com.